Hello. This is week 8, I think, our week 8 video. Today we will be doing um, more coding this week since today is kind of just a camera, but we will quickly review um, the 4 spaces that a game can exist in, and then cameras. So obviously the first 4 are model, world, camera, and screen. Um, One way to think of this is that um, usually model and world are self-intuitive, but model is is pretty much is just locally of the of the thing that is being drawn in this game or in this game engine. So, for example, our circle. Obviously, we have some sort of point 0, 0, and this could be the center, the model, or it can be the origin of the model. And then if you go, and obviously what we've done is that, so if you're drawing the rectangle, for example, so if we go into my engine asset, which will be discussed later, but basically what we have is we have an array of 4 points, and each point is in the model space of the game. Then what we do is then we can assign this model a transform. And what that does is it takes us model to world space. So say you're playing Silk Song, any popular game, obviously things are placed into the world. Like Hades 2, for example. The NPCs are placed in some sort of world coordinate space, and that's where they exist and wait. Um, so say, for example, even though that 0, 0 could be the origin of the model, in the world, it could be the origin. The origin could be at like 129 and 80. So, and then we project that onto the camera, what we are currently seeing. And this is where we apply the camera transform. Um, in this case, the camera transform is is a game object called camera game object, and it has a component called camera, and every single game object has a transform. And in this case, the camera transform is just where it is relative to the camera. So it's in camera space. So in world, it could be at 120, 80. In camera, we it could be technically negative 250 if it's not on the camera, for example, because um, usually the camera is um, is at the center, generally speaking. Um, and then finally, there's screen space, which the 0, 0 is at the top left corner of the screen or of the window, and that's kind of where everything is projected for you to see. Again, you need to really know how to transverse these because, say, for example, I click, it needs to go from screen to camera to world, and even to model if you need to know specific stuff where your model is being clicked at. So there's definitely some very useful things that come with that, and then we can even look at um, it would be in screen. Yeah, so when from going to camera to screen space, what we do is we translate. So we shift over half the width and half the height of the window, so that it gets centered, and then we translate based off of our camera position. Um, but one thing to note is that it has to be negative. it's not negative, then when we go left, it moves left. What happens is if you have your camera and you move left, it looks like the world is moving right. So you have to inverse your translate function from world to camera space. And then couple of the things we've done is that inside of here, now we have a game properties that has the layers. Apologies for that. And now what happens that inside of our scene, not scene, inside of our engine, we now have the layers. And when we start a game, so for example, inside of a weekly video game, now we input the new game properties in there. And in this, we'll have a lot of stuff, but right now, it's just in layers, which has a foreground. So that some game objects can be displayed differently in different layers. Layers is just like having clear paper on top of each other, and it allows you to draw specific aspects first. In this case, we filter out the UI because we do that at the very end. Because UI, we always want to be at camera space or basically on the screen. So we just save and restore for the game objects, and then we don't save restore for the next stuff. And then for game objects, is engine. What we do is now we loop through. So in this case, we first loop through the here, and we say, hey, draw all these game objects first, and then say if there was another one called foreground, then we draw these next. And those are labeled inside the game object, where now we have a layer now. Just one thing to consider. Otherwise, that's a pretty good, relatively good overview of all of it. Now we can continue to code some stuff. So if we look at, I kind of reverted back a little bit because I thought last week's was, there's some stuff I missed. So I just said, we'll just code it from the beginning to make sure it's very simple, logical, and that stuff. But what I did is I reversed it. I just followed what we did in class. We can kind of explain that, where inside of my player controller, what I do is whenever we update the position, we just set the camera transforms position equal to our current position. So now no matter what we do, it works with that. And then I have just a basic score on the top, just temporarily to show what's happening. So let's begin. So that's the first one we should do is climbable walls. We attempted this last week, and there's a lot of bugs and niche errors that kind of caused it to not be as good. Usually there is a better way to do this. So after looking into it, we currently implement on collision enter, but there's also on collision stay and on collision exit. Implementing those two aren't in the scope of this class, but can be done. So if you want to look into that, you could talk to me or Rix about it. But what's happening is we only have the on collision enter per se, which is just whenever you collide with something. So it is kind of different in a sense. But what I've done is I just have manually defined this so that it makes more sense. So the top, obviously, you're going upwards. That's why you subtract. Bottom is adding, left is subtracting, right. And I've done that for both this game object and then the other game object, just to make things way easier to explain. But um, and then obviously we have platform collision right here, where if we say, hey, if this bottom is greater than or equal to this top, then or other top, then we reset the jumps and do that. So one thing we could look at is see what that does. If we go back to here, one thing we can do is when we run it. So if we go on to the side, what's happening is now that I can always jump basically. So obviously there's going to be some things we want to change about that. So one thing many would think of is this, and if we do this, obviously jumps still work, and then if we go off to the side, we now do this. So now we're always falling. So now we can't hang on beside anyone. And so now if we go up to the wall, earlier you could do this, and now if we do this, we now just slide off the wall like nothing happened, like there's no force kind of acting on it. Okay, and then now the next thing we want to do is we want to create the wall game object. So we don't need the engine anymore. We can go to prefabs and have this wall game object pre-made. So this wall game object, you just call super for wall game object. You give it X and Y for scale. You add the polygon component, which gives you the squares this folder, which in this case is just an array of the points that we want. And then we do supply red so that we get the wall. Now when we add the collider, and now we have the this dot scale, and then we set the scale and that stuff. So inside of the scene, we have the camera, we have the score, the two platforms, and then we have the wall here. With a scale of 25/300 and a position of 800/600. So now how to do the wall. Well, first we need to check if we're colliding with the wall. So if we do other dot name equals wall game object, then we can say, hey, what we want to do is let's set this dot rigid body dot gravity equal to 0. Set velocity equal to 0. We obviously have, we now need to implement a side collision with wall. So that, hey, what are we in collision with the wall? This is kind of how we're going to communicate between the update and on collision enter. And then that's good right now. So if we're obviously impacting with the wall, we want to then do this dot side collision with wall equals true. And then the final thing is we want to reset our jumps. So that, hey, now we can jump. So if we just go back, now what should happen is that now if we're on the side, we're colliding, we can now create property X on number 0. Velocity.y. Apologies for that. Now, when we go into the wall, we need y on both. Gravity is a vector 2, and then velocity is obviously a vector 2, so we need y on both of those in order for those to work. Now when we go over here, now we can infinitely jump, and obviously there's kind of weird physics though. Obviously, there's no logic of saying, hey, now we're not colliding anymore. So now when we jump, we just always go up because now gravity is 0. So now what's happening is that when we don't reset the gravity or velocity. So inside of our update, we need to expand a little bit more now. What needs to happen is that when we go arrow left, so what we reset the movement, we don't have direction yet. So then what we need to do is if you go arrow left, what we can do now is we can say, hey, if we are on the wall and we go arrow left, let's just assume we go off the wall, because if we go arrow right, what will happen is that we'll still be in collision and it will still update saying, hey, we're in there. We'll call this, which means it's true, which means that it will update to true anyway. So if we just assume if we move left or right, this dot collision with wall equals false. So now if we move left or right, your collision with wall should be false. And then we need some way to reinstantiate the gravity. So now we need to do an if statement, or if it says, hey, if this not dot side collision with wall, we then say, hey, let's go to rigid body dot gravity dot y equals 512. And now what should happen is that when I walk up here, then I move off, I should fall off. I can now kind of fall down. Now we can have a couple more issues now. We can just spam this jump and then just climb this wall. Obviously, that's really fun, more interactive, and it's kind of deep for a platformer because there's no real push or none of that stuff. So there's a couple things we can do now. Now what we need to do is we need to implement a direction, because one thing we haven't really shown yet is that if we go over here, one thing we can do is that when we jump, we can push ourselves, force the player to go back, reattach the wall, which would be kind of more of a interactive type of thing. So, but if we're on this side of the wall, we need to know if we need to push off this way or if we need to push off this way. And there's the main way to do that is see which side of the wall you're on. So what we need to do is we need some sort of new variable now called, let's just call it jump x direction. And we can say that equals 0. And we assume it was 0 because a couple things that will be explained later. But now what we want is we want to check inside of the if statement to say, hey, if our player game object is less than or equal to the left side of the other side, what we want to do is we want to set jump x direction equal to -1. And I can explain that over here. So go over here. If our right side is less than or equal to the left side, so if our right side is less than or equal to the left side, then what we do is we set jump direction equal to -1. And then if this left side or this left is greater than or equal to the other right, then we set this dot jump direction equal to 1. What that means is if over here, if the left side is greater than the right side or equal to, then we jump right. And now when we jump, now there's a couple things we need to do. Obviously, we have we do the jump velocity, but now what we can do now is we can apply a force in the x direction based off our jump direction. So if we do this dot jump x direction, and then let's times it by 100, we'll see a couple issues, but currently we assume the only way to get off the wall is moving left or right. But if we jump, what happens, we're going to infinitely go up now. And that's because we're not resetting our gravity. We only reset when we move left or right. Now when we go left, we see now we're falling, and we will eventually get back down. So if we go over here and we jump, we move off the wall, which will avoid the collision, but now we have to move left or right in order to avoid that. We don't really want to do that. Now we kind of follow the same logic, where now we say, hey, this dot, we set this large collision with wall equal to false. And then we also, then another thing that I kind of like to do, just to make sure everything runs correctly, is that we set the jump x direction. We reset the jump x direction equal to 0, so that the next time we jump, let's see if this is necessary. So if we jump, and now we jump, obviously, yeah, it's not, I don't think it's necessary, but it's something, personally, I think it's really nice to have just to kind of clarify things. Now, when we actually look at it, if we go over, we can now angle on the wall. When we jump, we get off the wall, and then we kind of get our jumps back. 2, 3, and go back on the wall. 1, 2, 3, jump on the wall. And now if we walk off, we can walk off. Everything's working. So it's more of a bigger game engine. What normally how you would have it is you would kind of replace a lot of this logic inside of the on collision exit. So inside of like Unity, for example, there is a function called on collision exit, and it has the other. And you would do something very similar. If there's a log game object, if you're exiting the game object, then it would just be as simple as reset. You would do something as simple as resetting the gravity and jumps left. But in this case, we kind of have a situation where we don't have access to that. So we kind of need to find an alternative. And this is just one of the alternatives that was found. Kind of worked for me, logically. So now that we have wall game object, now we can kind of put walls wherever we want. I'll probably do some more scene stuff later on, but obviously that kind of makes sense. And now, before we go, we should also do this side. One thing you see though, if I can do it, like this kind of looks not weird, but it doesn't look correct. It's like you're hanging on the wall, but you're not really hanging onto the wall. You're above the wall. So one thing you can do is inside of here. Now, since we have everything labeled, it is as simple as hey, and if this should be say if we go what it should be is we should say let's actually visually show it. Okay. And what we kind of want is we want only this to happen if the object's top, or if our player's top is um, greater than or equal to this top. So we would need an and we would say this is greater than or equal to other top. Now if we kind of go over here, and hopefully if we collide with the wall, now we're kind of hanging on the ledge. But if we go up and we try and do a and now we can't really get onto the corner now, because now it's acting like we can't grab it until we hit that ledge. So you could kind of do the same thing with ledges. So say you want to make it so that there's only ledges that people can kind of grab. This could be something similar where you would say, hey, if ledge game object and this dot top is less than or greater than or equal to other top for the player character. And then what would happen is that they can only grab on the ledge. The same thing can happen is if you don't want if you only want the ledges, if you only want to grab on the ledge, then another thing you could do is something similar to this, where it would be you would count that out. We would say, hey, this dot top minus other top math.abs is less than this dot transform dot scale dot. Now what should happen is if I go down here, I just hang off the wall and then it goes by. But if hopefully I can get this. Yep, now I can kind of hang on the ledge only on the top. Now if we kind of jump, I can't hang on the ledge anymore. So if you want more of a ledge grab, then obviously you can adjust the scale.y to make it a little bit more accurate. And then you could even include this as well to make sure that it isn't, that if you go on the top above it, it kind of slides. So and now you kind of have that ledge. But I don't want that. I want you to be able to like climb the wall like a rock climb. So that's kind of what I'm going to do. But that's just an option. You only want to be able to hang on the ledge. But now, if you go back, we need to reload, I think. Now we can just hang it off. Now, obviously, another thing a person can do, which is what I'm doing right now, is if they just hold right in this case and spam jump, they kind of get this instance. And honestly, that's fine from my end if they want to do that. One thing you can always do is you could by a greater X force. It is just as simple as change this like 500. So now if they go, you can always adjust it as well. Yeah, that's kind of the wall climbing aspect of it. Now the next thing I want to show is a moving platform. What I have right now is inside a moving platform game object, which is a polygon, a collider, and a moving platform controller with a path list and a speed. And then obviously we have the X, Y path of speed on that. And then what we can do is inside of our moving platform controller, we just have very basic stuff. But obviously what we need now, since we need a path list to match this, and we also need speed. And we kind of need a little bit more logic. So the way I think of a moving platform is that you have an array of points you want to go to. Obviously, you have some sort of current point. You have your current index. And one thing we also need to do is we need to calculate the angle between our current point and our next point. So obviously, when we start, what we want to do is we want to say, hey, our current point equals this dot path list at index 0. We assume that whatever the first index is, that's where we're going to. So with this, we need to do the distance formula. So math dot square root this dot current point x minus this dot transform position dot x. So what this will do is we are trying to find the distance between where we're trying to go to and our current position, and then we square that plus, and the same thing for y. So we can just copy and paste this, and we change that with y. And then we need to make sure that it is squared. And now this is kind of arbitrary, this upcoming point, but say for our distance is less than some number n, which I'll say 5. Usually 5 is kind of a good number that I found. What we need to do is we need to say we now need to update the index because now we have reached that point. So now if we say this dot current index is less than if it is less than the pathless length minus 1, it is as simple now as implementing the current index and adding 1. But if we're at the end of the path list, we want to go back to 0. We need to set that back equal to 0. And then after we kind of do this update for distance, now what we do is now we say this dot current point now equals the path list of this dot current index. So when we approach the distance of 5, now what's happening is if we are less than the pathless length minus 1, then we just increment by 1. Otherwise, we restart from the beginning at 0. There's probably some other ways to do this, like using a modular function, but this is the way most intuitive. But if we are at a greater than or equal to distance of 5, what we need to do is we need to get theta. And means we have to use a tan 2. And what we do is we use this dot current and then this dot current. Now we use the difference in y and difference in x for the theta function. And then what we do is now we do now we update based on that. And dot x plus equals. So first we need to get the speed. All we do is we multiply the speed by the cosine. So remember that x is cosine. And then we times it by time dot delta time. And then sine is y. Now what happens is if we're not But if we're not close to the point, then we just update the position X and Y to go to that point. So kind of let's see what's happening on that. So if we go to the scene, what we can do is inside of the layout, we can instantiate a new moving platform game object. And let's do 50, 20. So that's the scale X, scale Y. And then we need an array of new vector 2. And we will need, let's just rotate between 3 points so that we know that it works. Let's do 1,000, 800, 100, 800, and then 1,200. And then outside of this, we have a speed of 50. And then outside of this, we need now a new vector 2 for our position. And let's do like 1,200. So now, if we go back over, we now have a moving platform. And let's just make sure that it loops correctly. Yeah, looks like it's looping correctly. So now let's try and stand on it. Oh. So you see how it's not, even though that I'm standing on the platform, my position isn't being updated when I am on the game object. So there is a good way and a bad way to do this, kind of logically. It kind of involves engine in order to do that, and I'm going to try and stick away with manipulating the engine. So the best way that I want to do this is if we just update the on collision enter. So just like the player controller, what I'm always doing now just to understand and simplify everything is we just have a reference to all this. The top, bottom, the left, and the right. And now what we want to do is we want to do an if statement, and we want to say, hey, if the other dot name equals player game object, we also want to make sure that this inside of our player game object or player game controller, we have that statement of this top is greater than or equal to other top. Sorry, this bottom is less than or equal to other tops that we don't move over like that. We want to do the same thing just to make sure that we can't hang on to the walls and have a big position. Because obviously we don't want them to wall climb on the moving platform. We want them to wall climb on the platform, the wall game object. So now, if this is the case, now we just do other.transform.position. Okay. The best way to do this is that we just update position, but for the player in this case. So if we go back there, instead of doing this instead of doing this, we just do other transform.position. Why? So now instead of saying, hey, we don't move, and it kind of just moves around, what we do is we actually move with the and again, there's a better way of doing this, but nope. Is it because of this? That might just be wrong. Um, so if we go over here, and now we're just moving along with it. If we go off the side though, we can't collide with it. Yeah. Um, that is pretty cool, but you see, if you saw something that if it was obvious, well, I think that looks good. But yeah. Um, Now we have a very basic moving platform. There might be some small bugs in there, but obviously I'll just have to play with it more in order to see what's happening. But obviously I think that looks good for right now. Um, and now the final thing I want to do is um, I want to make an enemy game object. So obviously every single game has some sort of, or not every, but most games have some sort of antagonist, especially with platformers. Um, Unless you're like Jump King, where the antagonist is yourself. So that's kind of how we do that. Obviously, um, just like for the rest of them, a basic enemy game object, which is a little bit more stuff, but all will be explained. We have a enemy controller, which we will create and add on to it, which is empty right now. We have a polygon, we have a collider, and then we have the health pool controller, and then a rigid body. Um, with our polygon, not polygon, with our enemy controller, we can look at the enemy controller, and we kind of have a couple things we want to do. Obviously, just like where's our player controller as a start, where we update the rigid body and gravity. We want the gravity to be the same across the entire game, so that I will do the same. And then also, since what's happening is that we will have a speed as well, and let's have a default speed of vector 2 and 0. And then we also have, let's do a damage as well. Just so that kind of we have everything laid out. What we want to do is we want to set this dot velocity, or this dot rigid body dot velocity dot x. Or no, we don't need that. Equals this dot speed. So update our velocity just to be the input speed that we want. And there is a couple of things we need to do. So since our velocity will always update our position, we don't need really anything or update just yet. But we kind of have a couple collision things that we'll see. The first thing that I always do is in here, copy and paste just to make sure it works. Or not it works, but it is more easily, the information is displayed. So now what we want to do is we want to make sure that the enemy stays on the platform. So if we do other.name equals platform game object, and what we want to do is we just want to make sure that the rigid body dot velocity dot y equals 0. And we also want to make sure that the gravity is 0 as well. Because obviously they're not jumping, they're not doing any of that stuff. So, and now there is a core concept that we need to do where if it is approaching the edge, the platform game object, what we want to do is we want to say, hey, either edge. So this means that if our enemy is approaching the other left, so if the left side of our enemy is approaching the left side of the platform, or if the this right is approaching the other right side of the platform, we could just do a simple velocity switch. So we're just by dot velocity dot x equals negative rigid body dot velocity dot x. Now, same thing with this is if we do if yeah, and let's actually see what's happening now. So go into our scene, and then inside of our scene, obviously we have an enemy. We have the new way of doing it. So let's say let basic enemy one equal new basic enemy game object. Then we instantiate the basic enemy one, because obviously there might be multiple enemies, so we want to distinguish between enemies. And then let's have, obviously the basic enemy game object gets a horizontal speed, which then is inputted as a new vector 2 for speed. So let's do 50 to make sure it kind of moves. And then we also need to do a new vector 2 for our position, and let's do 400, 200. And then finally, what we want to do is we want to instantiate a new health bar game object with the basic enemy one. Hopefully, we go in here, and now they have enemy. One thing you see is that their health is already damaged, and that's because max HP is 20 and current HP is 10. But now, obviously, now you see they're rotating on the platform, and they just go back and forth, but then hit the edge. Obviously, when we interact with them, there will be two things that happen. I will be able to push against it, and then I will also be able to not take any damage when colliding with it. So there's a couple things we also need to do for it. So this is kind of the reason. So one way to solve kind of this is become the gravity change out. So what will happen is that when I pushed off the ledge now, it should fall now. But what will happen is that it will accrue velocity in the y. So say if you apply upward force to it or something like that, then there might be issues. But as of right now, that's not really as important. So that is fine if we just ignore that. We assume that's going to stay on that platform. And obviously, this is a deeper issue since everything has a rigid body and collider in this. What will happen is that I can always interact with this. So what will happen later on, which I think is next week in class, we will talk about, just like there are visual layers, there's also collision layers that have happened. So we will do something like that, but until then, we also kind of want to be able to be damaged. So the way to do that is, so there's kind of a lot that can happen when we are damaged. Many of the times when you are damaged, there's an invincibility frame. Obviously, we could do other dot name equals player game object. And we can repeat this whenever we are in collision. But one thing I like to do is inside of the health controller, or in the the health pool controller. This is where we store our max HP and our other stuff. Inside of the pool controller, I kind of implement logic to apply damage and kind of that stuff to it. So what I can do now is is vulnerable, or sorry, is invulnerable, and we always set that equal to false to begin with. Invulnerable, let's say current time equals 0, and then invulnerable length equals 1. And what we do is inside of an update, there's a couple things we need to do. Obviously, if we are invulnerable, we need to reset or we need to increment the invulnerable current time. And we just need a plus equal time delta time. So if we're invulnerable, we increment the time. And then what will happen is that if this dot invulnerable current time is greater than this dot invulnerable length, what we do is we just reset invulnerable current time equal to 0, and reset is invulnerable equal to false. And now what we'll do is we will call this function now, which is just called apply damage, and it's given a damage. What this will do now is we'll say, hey, if not this dot is invulnerable, so if we're not invulnerable, this dot current HP equals math.max. So we want to make sure that we always have at least 0 HP. So this dot current HP minus damage within 0. And what we always want to do is we want to set is invulnerable equal to true after we get hit, so that we just don't instantly die if we collide for a little bit. And obviously, we also want if this dot current HP equals 0, what will happen is that this dot game object dot destroy. We will destroy this game object, and then boom. So now, inside of our enemy controller, what we want to do now is we want to now get other.get component. We want to get the health pool controller, and we want to apply damage. And then the damage we want to apply is this dot damage. And now, hopefully, there'll be a couple of issues that we will see. Hopefully that they're just apply damage. Oh, it needs to be equal. Okay. So when we collide, we are now getting damaged. We have now gotten damaged. We have now gotten damaged. Now we die. We can't control anything, but we still have our health bar there. So inside of our health bar controller, we kind of need to update some logic as well. So if we go back and we do, instead of the health pool controller, we go into the health bar controller. Obviously, what we do is we always update get the max HP and current HP. We always update the health percent and then the position, but obviously what we need to also look at is if this dot current HP equals 0, then we can just this dot game object dot destroy. And one thing to also note is that now a 1 second kind of think. 1, 2. Let's go to source and let's see what's happening. Components, controller. Hmm. Did I misspell current? Is it saying it is undefined? Yep, it is saying that it is undefined. So then that means inside of here, there's an issue with how we get HP. Entity docking component health. Is it? Oh, it's HP, capital H and capital P was the issue. Hopefully this works. Yep, and now it is deleted, and there you go. So now we probably off screen I'll make a better level, but now we kind of have a actual game now. Now we can climb up walls, have moving platforms. We have a jumping, triple jumping, that type of stuff. So yeah, I think that'll be it for today. If you have any questions, comments, concerns, you can note my emails on Canvas. Otherwise, you can always talk to me after class. This week, Monday, we don't have class. And Wednesday, we'll be doing kind of a big picture day like we did 2 weeks ago, I think.